Good morning, student. Myself is Dr.S.Rasheeduddin. Today we will discuss on the Minimax search algorithm in a artificial intelligence. Here there is one graph given here. Here in this graph, we have to find the path between a root node to the given child node. Here A, B, C, D, E, F, G. There are the some nodes are given. Here all the terminal utility values also scored here. Here by using this score, we need to find the path between a root node A to terminal node. All the terminal we need to find the path by using the min-max algorithm. Here the root node we will take a max function to evaluate the value. For the next level, we used to use the function min function to evaluate the value. After that, again we have to use the max function, and at the ground level there is no function will be evaluated. Based on these utility value, we have to find the utility value for the parent. How to find the utility value for the parent node? Here, in order to find the utility value for the parent node, we have to use the DFS algorithm. By using the DFS algorithm, we have to cover all the nodes which are there in a right subtree first, and we have to start visiting the nodes from root node to all the children at a level. And first we have to traverse the A node to B node, and from B to D node, from there D to our terminal node. Here, in order to find the utility value for the D, we have to consider the two terminals which are there for a node D, and by using the maximum function which is present at a top level, we have to use the top maximum function for finding the utility value for the root node D. Here, by observing this example, there are the two different values. There are two different scores are given for the D node. The one value is 10, the other value is 9. Here, by using the max function, we have to take the maximum value among the two. Here the 10 in a 10 comma 9, the maximum value is equal to 10. The same utility value will be covered to the parent. After finding the utility value for the node D, the same score will be carried to the node B. In the same utility value will be goes to the node B. Here, by observing this tree diagram, here there are along with the left subtree, it also have some right nodes, and how to travel from the node B to node E, and by reaching the terminal node, that is a very important point. Here we at the node B, we only have the utility value 10, but it also have the node E and the other terminal nodes. Here after finding the utility value for the B node, we have to traverse the node E, and after that, by taking after considering the E node, we have to take the two utility value for the E node. There are the two different values, 14 comma 18. It first visit the left child, that is nothing, right child, that is nothing but the 14 value. The same utility value will be given to the node E. After that, it will also goes to the terminal node 18. Here among the two, 14 and 18, the maximum function uses the 18 value and replaces with a 18 for the utility value for E. Considering these two values, by using the minimum function which is there to the root node, we have to take the minimum value between the two, 10 comma 18. That will be given to the node B. Here, by considering the value 10 and 18, the 10 is the minimum value, so the 10 value will be given to the node B. The same value will be carried to the root node 10 After that, it have a one more subtree, that is nothing but a left subtree from root node to the C node, C to F, F to G. Like there is a one more subtree is available at the left side. So it will pass after iterating, after completion of all the right subtree, it will goes to the left subtree and start visiting the nodes from C, and by using the DFS algorithm, it start the visiting from the root node to C node, C to F, F to terminal nodes. Here, when you visiting the terminal node, for node F, there are the two different values, utility values for the node F. Here 5, 4. Here, in order to find the utility value for the parent node F, it uses a max function. In a values 5, 4, the utility value, maximum value is a 5. So it will assign the utility value for F. See here, the F node got the utility value for 5. The same utility value will be forward to the node C. After that, it will have a one more right subtree. Here it will goes to the C to G, G to all the terminal node. Here for node G, there are the two different nodes are there, 50, 3. Here among these two values, the maximum value is a 50. So 50 value will be assigned to root node G. And by considering the values in a 5, 50, the minimum function will take the value 5 and it will assign the utility value for 5. And between the B and C, for finding the utility value for A, there are the two different values are there, 10, 5. By using the max function, it will take the value 10. 10 is the maximum value, so it will take the 10 value and it will gives the utility value 10 for a root node A. Given all the utility values for the entire tree, for finding the convenient path from the root node to the child node, wherever it has finding the utility value as 10 among the tree, it will select the best path, that path as a best path. See here, in order to finding the best path or a convenient path in a given tree is a to B, B to D, D to all the terminal node, left node, that is last. This node as a path from root node to the terminal node.